Hi Year 11. So let's start today with our retrieval roulette. So pause the video, answer these in your book, and restart whenever you're ready to mark and correct them. Okay? So here's the answers. First question was to state the equations of motion. So v equals u plus at, s equals ut plus a half at squared, v squared equals u squared plus 2as, and s equals a half brackets u plus v close brackets t. Or s equals u plus v in brackets all over 2 multiplied by t. Same thing, two different ways of writing it. The rest of them there I think are okay for you to mark from the screen. So again, pause, mark, fill in anything that you left out, and then we'll start on to our lesson. Now, this next little bit in your notes, page 204, if you don't recognise that or aren't there already, open. But it always is like, it feels a bit random to me, but I suppose it follows on from the stuff that we have just done on free fall. So it's really talking about all vertical motion under gravity, and basically what we're saying here is, unless they tell you otherwise, we assume there's no air resistance. So something falling will be in free fall. If it's going up the way, it's like the opposite. The only force that's acting on it is going to be its weight. So the force of attraction due to gravity. So it's like, I don't want to say it's like opposite free fall, but you know what I mean. Okay, so let's have a read through this, and then there is just one more example, but it'll do you no harm to have another example using those equations of motion, because these are the questions that we all find the most difficult. So when a body is thrown vertically upwards, its motion is opposed by the force acting on it due to gravity, and that is its weight. As soon as it leaves your hand, there's no longer an upward force acting on it. So by that we mean, like, you give it a force. Whenever you chuck it up, you're applying a force to it, but that, like, as soon as it leaves your hand, that force isn't there anymore. So as soon as it leaves your hand, the only force acting on it is its weight down the way, and it's going to be accelerating down the way due to gravity. So it's going to decelerate until it reaches the top, and then it's going to accelerate down the way. Okay, so that's just our little diagram for that. Because the resultant force is acting downwards, the ball will accelerate downwards, so decelerate upwards until it stops completely at the top of its flight and starts to accelerate downwards again. The deceleration on the way up and acceleration on the way down are both acceleration of free fall, which is 10 meters per second squared on Earth, and air resistance is negligible. So let's have a little look at the question to do with this. So page 205, a ball is thrown vertically upwards with a velocity of 40 meters per second. What height will it reach above the hand, and how long will it take until it is caught again? So here it is, and it's going to go up again until it reaches the top, and it's going to stop there, remember, and then it's going to come back down again and be caught at the same height. So it goes up with a speed of 40 meters per second, and it decelerates due to gravity, and then it stops. So the velocity here is 0. I don't want to write u or v because it'll be different depending which part we're looking at. In fact, I'll just write velocity equals 0. Then it's going to accelerate from 0 back down to the same height, and its rate of acceleration is the same as the rate of deceleration on the way up, which means that whenever it reaches this height, it's going to be going at 40 meters per second down the way. Does that make sense? I was almost going to say there it's like a mirror image. I suppose it's just like a reverse. So it started off at 40 here, decelerated until it reached 0, and then accelerated back down at the same rate as it decelerated on the way back up. So at the same height, it's going to be going at the same speed because all the values are the same. Okay. Now, what had this asked us for? What height will it reach above the hand, and how long? So let's use this little first section on the way up to get the height that it's going to reach. So for section 1, let's list our UVAST. So let's go up the way as being positive. Okay, so U is 40 meters per second. In section 1, that only takes us right up to the top, so V is 0. A is going to be minus 10 because it's accelerating down the way or decelerating up. S is what we're trying to find, and we're going to do T eventually, but not quite yet. So we're looking for an equation that links U, V, A and S. So before I say it, have you think yourself. V squared equals U squared plus 2AS. So V is 0, U is 40, 2 multiplied by A is minus 10, and then S is what we're looking at, or looking for, I should say. So 0 equals 1,600 minus 20S. Right, to get S on its own, I'm going to add 20S to both sides. Right, so 0 plus 20S gives me 20S. 1,600, take away 20S plus 20S, just leaves us with the 1,600. Then to get S, if we divide by 20, we will get that the height is 80 meters. That is some throw. So the height reached 80 meters. Imagine throwing something 80 meters up in the air. I don't know, is that possible? Not for me. Right. How long will it take until it is caught again? So if we just calculate the time up until the top, then all we have to do is multiply it by 2 to get the total time, because that'll give us the time up to the top, and it's going to take the exact same amount of time to come back down again. So now we're looking for T. Preferably I would like to not use S, because I've just figured out if I did that wrong. Oh, look, I never even showed that what I was writing there. If I did that wrong, then it's going to mess up my next one as well. So I'm looking U, V, A and T, the one everyone knows the best. V equals U plus AT. So V equals U plus AT. V is 0, U is 40, A is minus 10, and T is what we're looking for. So if I add 10T to both sides, then I'll get 10T equals 40. And then to get T on its own, I divide by 10. So it took 4 seconds to get up to that height. Now, that's only the time to get up to the top. So the total time is going to be double that. 8 seconds. That looks like 85. I promise that's an S. Now, this next wee bit is just showing what the velocity time graph would look like for this. And then we're going to use it to figure out all of these different things. Okay, now I already have this drawn. If you have graph paper, then draw this out. If not, then just on a bit of file paper, something so you can slot it into your folder. If you just even do as neat a sketch as possible for this, then it means you'll have it. Okay, so let me show you the graph and talk you through it. Right, axes first of all. We know that it was thrown with a speed of 40. And then we know that it's going to have reached minus 40 by the time it gets down on the other side, because 40 in the opposite direction. So we know that's what our y-axis scale has to go from. It has to go from minus 40 to 40. We've just figured out as well that the total time was 8 seconds. So our time axis has to go to at least 8. Now, if we refer back to this question, our initial velocity was 40. So at a time of 0, our ball has a speed of 40. We just figured out that it took 4 seconds to reach up to the top, and at the top its velocity is 0, so that's how we knew that point. Then we know that at 8 seconds it's back down to the same height again, so it's going to be at minus 40 because it's 40 meters per second, but in the opposite direction. So there are the 3 points. Then if you remember from velocity time graphs, a constant acceleration or deceleration is going to be a straight line. So it's just one big straight line joining these 3 points together. And then see this wee line here, that's just showing that in this fake scenario, it's taking 0 seconds for it to be caught. So this is it, like hitting the hand, and then whenever it hits the hand, it's going to go to 0. In reality, that's going to take a little bit of time, but we're acting like it takes 0 time at all here. Okay? So either get that drawn on a bit of graph paper if you have graph paper, or get that drawn down just on a even lined paper will do, and just do like every 2 lines is 10 or something like that. Do you know what I mean? Something so that it's neat enough. So pause, get it drawn, and then restart the video. So this is asking us to use our graph to calculate a few things. Some of them we have already. The total time the ball is in the air, well, that's the 8 seconds. So we'll just write that in there. The velocity it is travelling with when it is caught, well, we've already figured that out. That's the 40 meters per second downwards. Okay. The height reached by the ball. Now, I know we figured that up above, but we're going to be showing how we can get that from the graph. So if you remember, this is the point from where it was thrown, and this is the point that at its maximum height. And do you remember the wee rule that the area underneath a velocity time graph gives you the displacement? So if we calculate this area from 0 up until 4 seconds, that's going to give us the displacement between those times. And that's going to be the total height that it's reached, because at 4 seconds it was at its maximum height. So let's write that in there. So the height reached by the ball is the area under the graph from 0 to 4 seconds. Okay, now let's have a look. This is a triangle, so half times base times height. Let's have a look. Base is 4 and the height of the triangle is 40. So just be careful. One of the most common mistakes whenever people use graphs to get the area is that they'll like count the squares or count the lines or something rather than using the numbers on the axes. So make sure you do that. So a half multiplied by 4 multiplied by 40 gives me 80 meters. Is that the same as what we got up above? Yeah, height reached 80 meters. Good. So the total distance the ball has travelled in the air, the total distance is going to be the total area between here and here. I described that wrong. I'll start again. It's going to be the total area underneath this graph. So it's going to be this area plus this area here. So let's do that. Let me get this out of my way. So for part D, I'll go down here for it. It's the total area between the graph and the x-axis. So we've just figured out that this area is 80. This one's going to be 80 as well. So 80 plus 80 gives me 160 meters. And then part E, the total displacement of the ball. Well, to get the total displacement, really, technically, we're doing this area, and then we would take away this area because it's going to be the displacement in the opposite direction. So we're going to end up back at 0. The other way you could answer that would just be to think it through logically. This thing's ended up where it started, so its final displacement is going to be 0. Right, so hopefully that has made sense. What I need you to do now are some completely different questions, although some of this stuff might be intertwined in them. So let's see, for the rest of this lesson, if you do questions, let's go 1 to 5 on page 206. Okay, so questions 1 to 5 for this lesson, and then if you upload your answers, we'll be able to have a wee look at them. Okay, give us a shout if you need any help or if you're stuck on questions. Oh wait, make sure that you, like, whenever you get these, it's likely that you're not going to know what to do straight away, so get into the habit of looking back through your notes to help you, or like, yeah, to help you get started. Okay, but yeah, you can obviously always ask for help as well, but let's try and use our own brains a wee bit. Right, that is me actually now, so I'll see you then. Bye.